Addition theorem. As I said you that another three theorems where you don't have proof, just you need to remember the statement while doing the problem. So no theorem statement is required. So if you consider two events A comma B, addition theorem we use the word or and the symbol union. Addition theorem is used for using the word like or symbol U. So if A and B are any two events, probability of A or B, we write that as probability of A union B, which is given as P of A plus P of B minus P of A intersection B. Okay, addition theorem is either R or U. P of A union B is equal to P of A plus P of B minus P of A intersection B. So whenever A comma B are mutual, we have special case whenever they are mutually exclusive, A and B are mutually exclusive, then P of A union B simply is equal to P of A plus P of B. So these are the two statements for addition theorem. This is for the first statement is for any two events, and when A and B are mutually exclusive, this part disappears. Only you will get probability of A union B is equal to P of A plus P of. If you have three events, P of A union B union C is equal to P of A plus P of B plus P of C minus you will get P of A intersection B, three combinations AB, BC and AC. So this is very rarely used. The problems also you will get only for two events only. You remember these two. So let us do the problems on this. So if you go to your page number 245. Okay, page number 245. So the managing committee of a Vaishali Welfare Association formed a subcommittee of 5 persons to look into water and electricity problems. Profile of 5 persons are given. So look into this your page number 245. You can understand it. Some data is given where some female, male, again male, female, male and their age, the sex of the particular persons in the committee and their respective ages are given. Means there are, the question is, the managing committee of a welfare association formed a subcommittee of 5 persons. There are 5 persons in the committee to look after water and electricity problem, and there are means the number of persons in the committee. What is there is a committee with 5 members. So total persons in the committee. Committee is 5. So we can say take total number of events as 5 with the first line, and the age of there are the age and their composition is given. Now the question is nothing but if a chairperson has to be selected from this, what is the probability that the chairperson would be, if a chairperson is to be selected, if a chairperson is to be selected from these 5 members. How many members are there from these 5 members? Okay, what is the probability that either female, would be either female or over 40 years. Okay, it is given that there are 5 members in the committee, and if one is to be elected as chairperson, what is the probability that the chairperson is either female or over 5 years? So I think in this probability the question we are observing a word called either or, which indicates that, as I said you, it's a we should able to understand that it's a problem on addition theorem. It's a problem on addition theorem. So let A be the event of selecting. Let us take the first event as A. Let A be the event of selecting a female person as chairperson, and B be the event of event that he is of age over 40 years. Now, is there any combination? That means you are going to find out P of A union B. Means what is the probability that either he is the chairperson is female or over 5 years. So or means, as I said, you should use A union B. P of A union B is P of A plus P of B minus P of A intersection B. So we are going to use the addition theorem here. So what is P of A? P of A means total number favorable number of events by total number of events. What is the total strength of the committee? There are 5 members. What is the event A indicating? Event A is indicating a selecting a female. How many females are there in the given one? Male, female. Male means there are 2 females. So there is a chance that 2 by 5 that the selected chairperson is female. What is P of B? Again favorable by total number of events. What is the total number of persons? 5 here. Now, what is the probability that selected chairperson is over 40 years of age? So, if you go to the age column, over 41 we have 41, 43, 65. We have 3 numbers representing above the age 40. So, you will get 3 by 5. So, what is P of A intersection B? A intersection B means probability, and intersection stands for and. Probability that he is a female and above 40 years. As the statement involves P of A, P of B and P of A intersection B, we have calculated P of A, P of B we have calculated. You need to find out P of A intersection B. Intersection means and, probability that he is a female and above age 41. So is there any person, total is no change 5 here. Is there any event that representing above 41 years? I think above 40 years. What is the probability that event of female and person over 40 years of age means we have or 40, not 41, or 40 means you have 41 as the number. So we have 1 there. So you will get over 40. I think we don't have male here. I think there is a correction in your book. So we have no such person. No female is aged above 40. You will get 0 here. So P of, there is a correction in your textbook. Please look into that. P of A plus P of B minus P of A intersection B. So which is nothing but 2 by 5 plus 3 by 5 minus 0, which is nothing but 5 by 5. Okay, this is the first problem here. Similarly, we have another problem. Let us discuss that also. One ticket in the same page number 239. One ticket is drawn from a big basket containing 50 tickets numbered from 1 to there are. What are the total number of tickets here? Always you try to identify total number of items or tickets. Here we have total 50 here. Now find the, what is the first question here? What is the, find the probability that when one ticket is chosen, it is a multiple of 5 or 7. As I said to you, whenever you have a word called R, you should go for addition theorem. Means you should make use of the statement of the addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. You need to calculate the individual probabilities. Now, as you have, it is the probability of selecting 5 or 7. Let A be the event of indicating it's a multiple of 5. B is nothing but event that multiple of 7. So, A means between 1 to 50, how many are multiples of 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Within, try to identify the multiples of 5 in the range 1 to 50. Similarly, B will be the set of events multiples of 7. These are nothing but multiples of 7. Now, is there any intersection, as we have saw in the previous problem, any female over age 40? Here identify which are common to intersection, means common to both A comma B. I think we have 35 as the common event to this. How many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 multiples of 5 and there are 6 multiples of 7 and you have 1 here. So what is P of A? Favorable by total number of events. What are the total tickets here? 50. 10 by 50. What is P of B similarly? 6 by 50. What is P of A intersection B? 1 by 50. So P of A union B will be, okay, P of A union B will be 6 by 10 by 50 plus 6 by 50 plus minus 1 by 50, which is nothing but 16 by 50 minus 1 by 50, which is nothing but 15 by 50. Seven, 14, 21, 28. I think we have one more number here, 42. So it will be 7. 17 minus 1, 16 by 50 is the answer for the required one. I think that in your textbook here also we have a small change because they neglected this intersection part. So in the similar way you can try this also, the second multiple of 3 or 5. Okay, so you have we have another problem also. Let us discuss another problem on this also. We can do the third problem you can do easily. What is that one? 3 unbiased coins are tossed. So when we toss a coin, for what is the basic outcomes of a coin? Head comma tail. Yeah, so basically we have two outcomes. When you toss one coin, total will be 2 power 1. Total events will be, when 2 coins are tossed or it is tossed for twice, you will get 2 square as 4. When we 3 coins or it is tossed for 3, 2 to the cube 8. When we don't get generally how many basically we have number of units, and you should raise the power by number. If 2 coins or it is tossed twice means 2 square. 3 coins means it is 2 cube. So here it is given that the coin is tossed for 3 times. So the total outcomes are, what are the total outcomes? I think you know that head, tail, HTH, THH, HTT, THT, TTT are nothing but the possible outcomes here. Now what is the question? We have identified total events as 8. Now let us look at the first bit. What is the first one? Probability that all are heads. Probability all heads means again favorable number of cases by total number of cases. From this problem, all are heads means all 3 should be heads. How many are there? Such events you have only 1. So 1 by 8 is the probability. What is the second one? Probability that there are 2 heads. Again favorable heads, favorable by total number of, no change in the total events. So 8, how many 2 heads we have? 1. There are 2 heads. This is one event representing 2 heads. 1, 2, 3. We have 3. 3 by 8. Similarly, 1 head, you have only this one. 1, 2. 2 by 1 head means you have 1, 2, 3. 3 by 8. Similarly, we have the word like at least 1 head. What do you mean by the word at least? If I say that to clear your paper, you should get 40. At least 40 means 40 or more. At least means that or more than that. At least 1 head means 1 head or more. Means maybe 1 head or 2 heads or 3 heads. Means you should calculate how many are with 1, 2, 3. You will get that as 7 by 8. Okay. This is the problem on the coins, and you can try the remaining problems also. Okay. Okay. Thank you.